What up, calculus students? Mr. Master coming at you. First homework video of the year. We'll have homework videos that I'll create this year if I ever change up the homeworks from last year to this year. You'll see some homework videos were created in previous years. They're good. But it's something I'm giving to you guys so that you don't need a tutor. So that if you ever have a question about how something's done, you can hear me walk through things step by step on how I would do it. If you do see a tutor, please have them reference these videos for like focuses and for the understanding of like how maybe I'm approaching the subject. And I think it'll help overall you be more efficient in the learning process. We are reviewing the unit circle. We're reviewing trigonometry, and you can see in the instructions the goal is to do these without the creation of the unit circle. Trigonometry will just show up randomly in this class, and you just need to be prepared for it. And again, we're going to try to be efficient. We're going to try to work on just understanding things versus memorizing things in this class. So we want to understand why the cosine of pi over 4 is root 2 over 2. And how I remember this is I understand three triangles. It's really two triangles, each with an hypotenuse of 1. These are right triangles, obviously. And the side lengths of these triangles with a hypotenuse of 1. We have our 45, 45, 90 triangles, which occur at the pi over 4s. And then we have our 30, 60, 90 triangles. If the hypotenuse is 1, the longer side is root 3 over 2. The shorter side is 1/2. I know this because root 3 is bigger than 1. So root 3 over 2 is bigger than 1/2. And these occur at the pi over 3s versus this different orientation of the 30, 60, 90 triangle where it's the short side going up. That occurs at the pi over 6s. So cosine pi over 4, I know pi over 4 is in the first quadrant. I'm going to draw a little guy, say, okay, there's pi over 4. Boom, I can drop that down. I can know that these are the lengths. Cosine from SOHCAHTOA is the adjacent over the hypotenuse. We don't have to worry about the hypotenuse because the hypotenuse is always 1. So whenever we divide by the hypotenuse, we are not going to change it. So the cosine is just the adjacent. And for all of our triangles in the unit circle, the adjacent's always the horizontal side length or the x distance. And then if you go on to memorize the unit circle, you think of it as the x coordinate. But like, boom, root 2 over 2, done. This triangle there. Sine of pi over 3, I'm going to understand that pi over 3 creates a 60-degree angle. So the tall 30, 60, 90 triangle, I know that this side is going to be the longer side and this side is going to be the shorter side, or I just kind of come back to this triangle. And I know sine in SOHCAHTOA is opposite over hypotenuse. The opposite is always going to be the vertical length, the y length, or the y coordinate. So that's why I know this is root 3 over 2 without using the unit circle. And if I'm doing this myself, I'm doing it in my head. And if you guys do this in your head, that's fine. What we don't want you to do is like feel like you have to write down the unit circle to do anything trigonometry wise. You want to either have it in your brain and maybe keeping these triangles in mind helps you from not like having it memorized versus just like understood. Tangent of pi over 6. So we're going to go to this triangle, the pi over 6 triangle. We're going to be in the first quadrant. And we have tangent, which is opposite over adjacent. Opposite is always going to be the y to the angle, and the adjacent is always going to be x. So I'm going to do the y over x. So I have this 1/2 divided by the root 3 over 2. And I know that with dividing fractions, it's the same as multiplying the top by the reciprocal of the bottom, or you heard of keep, change, flip. And we know that if you're multiplying two fractions, you can multiply straight across. And you can see you have 2 over 2 root 3. The 2's can cancel or divide the top and bottom by 2, which is allowed. And you have 1 over root 3. This is an acceptable answer on free response on the AP test. However, you need to be prepared for a multiple choice question on the AP test to be rationalized. And we rationalized, I think we talked about it in class, because back in the day, when people used to do math by hand and then they have calculators, this was like the easier way to find the value is to to write out root 3 and to try to divide that by 3, having 3 on the outside of the division versus the other way around is a lot harder. So now we venture into other quadrants. So the sine of 5 pi over 6. So 5 pi over 6 is 1 pi over 6 away from 6 pi over 6. We always kind of try to reference pi or 2 pi or 0. And we kind of go left, or we subtract or add angles to help us. Remember, going around counterclockwise is adding with angles. And then going clockwise is subtracting. So when I go to 5 pi over 6, I go to 6 pi over 6. Now that's another way to write pi is just 6 pi over 6. And then I'm going to subtract a pi over 6. Pi over 6 being 30 degrees gets me this short triangle in the second quadrant. The only thing we have to worry about in this second quadrant is that this x distance, if we're thinking about being on the xy axis, is like a negative x length. So this would be a negative root 3 over 2. However, the sine and the opposite and the vertical side length is still positive 1/2. So I'm just going to say that the sine is 1/2. Again, sine SOHCAHTOA, opposite over hypotenuse. The opposite is a half. The hypotenuse is 1. I don't have to worry about that 1. Okay, so finding the location, very important. 4 pi over 3. Again, I'm going to come over here to pi, which is 6 pi over 6 or 3 pi over 3. And then I'll add a pi over 3. A pi over 3 creates this tall 30, 60, 90 triangle. This tall 30, 60, 90 triangle in this quadrant would have this side length, which I'll say is negative root 3 over 2 because I'm going down on the xy axis, and this side length negative 1/2 because I'm going left on the x-axis. So these would be like the x and the y coordinates, or like the displacements of x and y. So cosine, again, adjacent. Adjacent's always the horizontal side length. It's always the x distance or the x coordinate, the x displacement or the x coordinate. Okay, 7 pi over 6, I'm going to come over to 6 pi over 6. I'm going to add a pi over 6. A pi over 6 is going to be the same as a 30-degree angle, creating this short 30, 60, 90. So with the short 30, 60, 90 triangle, I'll have the smaller side and the longer side looking like that. And the tangent will be opposite over adjacent. So it'll be just like this tangent of pi over 6, only negative divided by a negative. And we know that negatives divided by negatives are positives. We like to say that we are not good at math. What does that mean if we're not good at math? We are good at math. I like to say I'm not a good teacher. And you might have to think about that for a couple seconds, but then you realize that, oh, he thinks he's a good teacher. What about 11 pi over 6? Well, I'm going to come all the way around to back to where I start, which is at 0, but back to where I start after going around the circle is at 2 pi. I've gone around the circle to 2 pi. We have this first instance of a coterminal angle. They're at the same location, but they're different angles. 0 is no angle. 2 pi is around the entire circle. They end up in the same place, but they're different. And 11 pi over 6 would be 1 pi over 6 away from 12 pi over 6. Now think about this. This would be adding. This would be subtracting. So go around clockwise is subtracting. Gives me this 30-degree angle in the fourth quadrant. The adjacent side would be the longer side of my 30, 60, 90 triangle. The opposite side would be the shorter, would be the negative side length as well. So that's how I'm going to get root 3 over 2. I'm just going to kind of quickly do these, see if you follow along. If you don't follow along, go back to the referencing of the triangles. What we don't want you to do is have to create the unit circle, but not really, but have that as like a memorized portion of your brain rather than an understood portion of your brain. All right, so 2 pi over 3, this is going to be root 3 over 2 because I'm going to be here. This is 1 pi over 3 less than 3 pi over 3. We're going up. 5 pi over 3 is going to be 60 degrees down here, 1 away from 6 pi over 3. Subtract pi over 3 from 6 pi over 3. We'll have a negative opposite and a positive adjacent. I'm going to have my first negative root 3 over 2 over 1/2. And what we'll find is that the 2's will cancel. And we'll just get negative root 3, and we do not have to simplify it because you can't. Secant's the reciprocal of cosine, so I'm going to find the cosine of 5 pi over 3 first, and then I'm going to flip it. 5 pi over 3, we were just there. Big, tall 30, 60, 90 triangle, short side, long side. This is going to be 1/2. Flip it, it's 2. Cosecant's the reciprocal of sine, so I'm going to find the sine of 4 pi over 3, and then I'm going to flip that. 4 pi over 3 would be 1 pi over 3 more than pi. Here's 3 pi over 3, add a pi over 3. You get 4 pi over 3. You could have also like subtracted 2 pi's over 3 to get to 4 pi over 3 from 6 pi over 3, 6 pi over 3, 5 pi over 3, 4 pi over 3. So that's minus 60 degrees, minus 60 degrees. Or start from 3 pi over 3, add a pi over 3, add a pi over 3 to get to 5 pi over 3. Anyways, we're here. We can see we are big, long side, short side. The sine of 4 pi over 3 is going to be this negative root 3 over 2. I'm going to flip it, and it's going to be negative 2 over root 3. Cosecant is just the reciprocal function. I'm going to rationalize this just in case we have a question on a multiple choice question on the AP test. And multiple choice question answer choices are usually rationalized. But on free response, we are allowed, and on your quiz, you're allowed to put that down, but we recommend that you always be prepared to simplify. Okay, cotangent is the reciprocal of tangent. I don't think about tangent and then flip it. I think about tangent being opposite over adjacent, so cotangent is the adjacent over the opposite. I think that's a little bit easier to do with cotangent versus finding the tangent then flipping it, if that makes sense. So tangent, I'll say that again, tangent of an angle is opposite over adjacent. Cotangent of an angle is going to be adjacent over opposite. So adjacent is negative root 3 over 2, the longer side of a 30, 60, 90 triangle. Opposite is negative 1/2. So I'm going to do the negative root 3 over 2 over the negative 1/2. I can kind of see that it's going to be the same as this work up here, only a negative divided by a negative, not knowing what I'm doing. What happens on these quadrantial angles? I like to call them the extremes, where you don't really see a triangle, like at 0. Well, there is a triangle there. It's just the triangle is a very weird triangle. I'm going to just not really show what it looks like correctly. Imagine there's a triangle where the hypotenuse is 1, and then one of these two lengths is also 1, and the other length is 0. This is how you could think of why is the sine of 0, 0. Most times math teachers say, well, you're just memorizing the x and y coordinate. So what is the y coordinate at 0? The y coordinate at 0 is 0, and you go with that. I prefer to kind of think of it always as SOHCAHTOA and being opposite over hypotenuse, and the hypotenuse will always be 1 on our circle with a radius of 1. It's just like, what is our x or y distance or displacement? I say displacement because it could be positive or negative. So that's why I say the sine is 0, because it's opposite over adjacent 0. I go to the right 1. I don't go up or down at all. Versus the cosine of 0, well, if you continue to think about this triangle that exists here, which exaggerated looks like this, where this hypotenuse is 1, the opposite length is 0 because I'm not going up or down at all, but this adjacent length is 1. This is why I know, or I think of the cosine of 0 as being 1, because the adjacent is 0, the hypotenuse is still 1. Cool? Or you could just think of x, y coordinates if that's what you're familiar with and you don't want to try to follow this. Why is the sine of pi over 2 1? Well, at pi over 2, which is 90 degrees, we're going straight up and down. Well, you can imagine, this is an exaggerated look at what is going on here, is that the hypotenuse is 1, the vertical length is 1, but the horizontal length is 0. There's no x distance here to get up to this location on our unit circle to create this kind of triangle. So if you think about that, boom, sine opposite over hypotenuse, 1. 3 pi over 2 is 1 pi over 2 away from 2 pi over 2, or it's this straight down angle, 270 degrees, if you like to think about degrees. I don't. I like to just stick with radians and understand radians. And again, we kind of create this triangle down here, exaggerated, where we have the hypotenuse is 1, the vertical is 1, but the adjacent is 0. So the cosine is going to be 0 because there's no left and right. We don't go left and right. We do go down 1, so I should kind of consider this to be negative 1. So if I ask you what is the sine of 3 pi over 2, you'd say that's a negative 1. Because of this triangle that's created, or because of the y-coordinate, this is a true statement that like the y-coordinate on the unit circle is going to be the sine of the value. But I like to just always keep in mind SOHCAHTOA, keep it back to like the geometry things that we learned back in the day. Pi is all the way over here on the left. And if you think about sine, you're not going up or down at all. This kind of exaggerated triangle has a hypotenuse of 1, it's got an adjacent of negative 1, and it's got no vertical distance, which is why the sine of pi is 0. Tangent 3 pi over 2. Well, tangent's opposite over adjacent. It's the y over x. It's the vertical over horizontal. The vertical is negative 1. That's the opposite. The adjacent, the horizontal, is 0. You could think y over x, so I'm at 0, negative 1 if you want to. Or you could think this exaggerated triangle over here, where we have a hypotenuse of 1, a vertical length of negative 1, and a horizontal length of 0. Opposite over adjacent. Okay? So that's how I do things. Again, I don't really care how you do it, but our goal is not creating the unit circle. Our goal is understanding the unit circle and not necessarily having this memorized, but having this in a place in our brains where, whether it's memorized or not, is fine. If you see it randomly, it just pops up all of a sudden. Oh, I have to find the sine of pi over 3. I don't have to spend a lot of time creating the unit circle. Okay. So that's our goal, is to get there. Now, we talked about in class how it is the trig function of an angle that equals a ratio. Cool. What we were doing was given the trig function and the angle, and we were finding the ratio. This is, the adjacent over the hypotenuse, the ratio that exists in a right triangle at this angle. Well, now we have the trig function, we have the ratio, we are finding the angles. So our goal is to find angles. And this this causes problems a lot for like this question. People are like, oh, this is 1. Because it's like cosine of 0 is 1, but 1 is not the answer. So we'll talk about how we want to think about what are the triangles, or where are the triangles, and what angles create the triangles in which the cosine of that angle is 1/2. Now, what I like to do is the following. Again, keep my triangles in my brain. I got my pi over 4 triangle, my pi over 3 triangle, and my pi over 6 triangle. Pi over 4, we know the opposite and the adjacent are both root 2 over 2. Pi over 3, we got root 3 over 2.5. And then pi over 6 is going to be the opposite. This is going to be root 3 over 2, and this is going to be 1/2. Maybe I could be a little bit more exaggerated. And what I like to do here is think, okay, when do we have an adjacent side in SOHCAHTOA, adjacent or x side, because this is adjacent over hypotenuse. When do we have an adjacent side and a horizontal side equal to 1/2? Well, I can see this is my triangle, the pi over 3 triangle. Cool. Now, let's say this is negative 1/2. I would still start with understanding this pi over 3 triangle. I get the adjacent side as 1/2. But then I use one more little trick. I don't like to think of it as a trick. It's just an understanding of the quadrants and why certain trig functions are positive in certain quadrants. It's called All Students Take Calculus. And it's just helping you remember which trig functions are positive where. So sine, all of the trig functions are positive in the first quadrants because the adjacent and the opposite sides are going to be positive. Whatever triangle you create here. Sine is positive in the second quadrant because we have vertical lengths that are positive. We're going up. But cosine is going to be negative because we're going to the left. Tangent's going to be positive in the third quadrant because we got negative x's and negative y's. So whenever we divide a negative by a negative, we'll get a positive, which is why tangent's positive. Then cosine's positive in the fourth quadrant because we're going to the right and we're going down. So I want the pi over 3's where cosine is positive. So that means I want the pi over 3 in the first quadrant and I want the pi over 3 in the fourth quadrant. Well, this pi over 3 is pi over 3. This pi over 3, well, how do we get there? Either 3 pi over 3, 4 pi over 3, 5 pi over 3, or 6 pi over 3 minus a pi over 3 is 5 pi over 3. And these are my two angles. I have a lot going on here. I'm sorry for being messy, but hopefully you understand. That's why I like videos versus keys, because like, I don't know, you can follow along with my mess a little bit easier if it's a video. Okay, sine of an angle equals -1/2. Okay, I'm going to go to this triangle, the pi over 6, because this is where sine being opposite over hypotenuse, this is where sine will equal 1/2 at the pi over 6. And then I'm going to think to myself, okay, pi over 6 is where sine is negative. And I'm going to go to this pi over 6 and this pi over 6. So what are those two pi over 6's? 6 pi over 6 plus a pi over 6 is 7 pi over 6. And then 12 pi over 6 minus a pi over 6 is 11 pi over 6. Okay, a lot of you don't like radians, but embrace them. Pi over 6 is just 30 degrees. Think of 2 pi 360, pi 180, pi over 6, 180 over 6, 30. Pi over 3, 180 divided by 3, 60. Pi over 2, 180 divided by 2, 90. All right, cosine, -√3/2. I'm back to this triangle. Why this triangle? Because the adjacent side is √3/2. But now I need the pi over 6 triangle in the places where cosine is negative. So I'm going to go in the second and the third quadrants, here and here. So that's going to be 5 pi over 6, 1 pi over 6 less than 6 pi over 6, and 1 pi over 6 more than 6 pi over 6. All right, what about the extremes, the quadrantial angles? Well, you can think about where on the unit circle where our adjacent side be 0. You can think about where do we create a triangle where the hypotenuse is 1, but the x length is 0. And that's going to be up and down at pi over 2 and 3 pi over 2. Cool? Back to an easy one. Sine, is this easy one? I don't know. Sine is √3/2. I'm going to go to the pi over 3 triangle. Pi over 3 triangle because the opposite's √3/2. The hypotenuse is 1. So I want this pi over 3 where everything's positive, and I want the pi over 3 in the second quadrant. So that's going to be 1 pi over 3 and 2 pi over 3. Where will the adjacent side, what angle will the adjacent side equal -1? Well, over here, we'll have a triangle created where the adjacent's -1, the opposite 0, and the hypotenuse is 1. So we get that this is at pi. Should have said theta up here. What about this? This is a question that causes some students problems because they think that it's when sine equals cosine. And they're like, well, sine equals cosine, and they're both positive at pi over 4. This is almost correct. There's actually two answers. It's pi over 4 and 5 pi over 4. How do we know that? Well, one way for you to understand this is to divide both sides by cosine. Why do I do that? Because it creates this problem, tangent equaling 1. Now, where does tangent equal 1? Well, which triangle works out like that? The pi over 4 triangle. because the pi over 4 triangle, the opposite and the adjacent are the same. However, if you think about all students taking calculus, tangent's also positive in the third quadrant. So I would need the pi over 4 here and the pi over 4 here to get both angles. So a lot of people think sine and cosine have to be positive, but they could be the same value and be negative. So that's kind of what we do over here to answer that x could be 3 pi over 4 or 7 pi over 4. My penmanship is really, really messy early on in the year, and it doesn't get much better throughout the year, but it will get a little bit better. It's just like I have this little thing, and I took a summer off of doing anything math related, so I'm a little rusty. Why is it 3 pi over 4? 4 pi over 4 minus a pi over 4. Why is it 7 pi over 4? 2 pi, which is 8 over 4, minus a pi over 4. 7 pi over 4. Cool? When is sine 0? When is the vertical or the opposite 0? That's going to be here, where we do not go up or down anymore. The vertical side is 0, the adjacent's 1, the hypotenuse is 1. So this is going to be 0 and pi and 2 pi. These are all included between 0 and 2 pi, and we will put all three of them down, even though 0 and 2 pi are coterminal. They are different angles. When is tangent 0? When is it opposite over adjacent 0? So just remember that 0 over a number is 0. It's like this times this is this. Remember, a number over 0 is undefined. How do we know that? Like, think about 8 divided by 2 equaling 4 is what I tell all of my students, my geometry students. 2 times 4 is 8. Well, let's think about 1 over 0. Does this equal 0? Well, think about like rewriting this as multiplication. 2 times 4 is 8. Does 0 times 0 equal 1? No. So this is why that's not true, and this is undefined. So I want the opposite to be 0. I want the adjacent to be plus or minus 1. So where do we have the opposite or the vertical or the y to be 0? The y is 0 at the horizontal zeros. Okay, so I'm going to have the same answer as here, 0 pi and 2 pi. Answer to this is 3 pi over 2. And the answer to this, we're going to go to the pi over 3 triangle. The pi over 3 triangle has a adjacent side of 1/2. But I want the pi over 3 triangle in the second and the third quadrants where cosine is negative because it's positive in the first and the fourth. So the angles are at 2 pi over 3, 1 pi over 3 less, and 4 pi over 3, 1 pi over 3 more than 3 pi over 3. Okay, now, what happens if there's more stuff inside our trig function? It's this trig function of this expression where x is going to be our solution. So x is our solutions. But pi x over 2 are angles. So it's like our solution times pi over 2 gives us our angle. What we like to think is like we start out where our angles have to equal, well, what do? We did 2 pi over 3 and 4 pi over 3 for the previous one. But now we start talking about all possible solutions, and a key concept to the unit circle is understanding that we could go around the unit circle by adding 2 pi. This will be like adding 6 pi over 3 to get to 8 pi over 3. 8 pi over 3, the cosine of 8 pi over 3 will also be, let's go over here and go to 2 pi over 3 and add 6 pi over 3 to get to 8 pi over 3. The cosine of 8 pi over 3 is the same as the cosine of 2 pi over 3. 8 pi over 3 and 2 pi over 3 are two different angles, but they end up in the same location and they have the same characteristics. And we can just keep going around the circle over and over and over. This is why we talk about like adding and, from your pre-calculus class you call the Ks. So 2 pi k. Adding multiples of pi, whether they're multiples of 2 pi, going around our circle where k belongs to the integers, which means it could be a positive or negative whole number, which means we can subtract 2 pi and come around to negative 4 pi over 3, and that's actually going to be the same location, and it will be an angle. So it's the idea of like the coterminalness of angles. So these are all of our possible angles. But to get our solutions for x, we need to solve for x. How do you solve this expression for x? If it was like pi x over 2 equals just like 4, well, you'd be like, oh, I need to multiply by 2 and divide by pi. Well, we're going to do that for everything. We're going to multiply by 2 and divide by pi. Now, multiplying by 2 is like multiplying by 2 over 1. Dividing by pi is like multiplying by 1 over pi or multiplying the bottom by pi. We notice that the pi's will cancel, and then we'll just double the numerator. So we get 4/3. Multiply by 2, divide by pi, 8/3. Multiply by 2, divide by pi, well, put this over 1, multiply by 2, divide by pi, this becomes 4k. So it turns out if we want our solutions, any solution, we want to take 4/3 and 8/3 and add 4 multiples of 4 to it to get all other possible solutions. And that's the idea. As we start with angles, we manipulate it to get solutions. Cool? All right, sine equaling 0. Let's start with our angles. Where sine is 0, that's when I'm not going up or down at all. Is at 0, pi, and 2 pi, and all coterminal angles. We could literally just say it's like pi k. If you do pi k, like it hits 0, it hits pi, 2 pi, but whatever. Let's just like, don't stress about it. This is correct. And if we take these angles and we multiply it by 4, we'll get our solutions, which will be like 4 pi, 8 pi plus 8 pi k, or it'll just be multiples of 8 pi. I'll write out here, maybe like just don't stress, this is correct, but you can just say these are all multiples of 4 pi. But like, don't worry. It's fine. Just stick with this. I don't want to stress you out. What does cosine equals 0? Cosine equals 0 at the verticals. So my angles, all of my possible angles, 2 pi thetas, or my angles, are at the pi over 2's, the 3 pi over 2's, and all coterminal angles. Should be using like brackets around this, just to be a little bit neater in our notation. I think in pre-calculus, maybe they separated it out into two things, but this is fine if you use brackets. And then what do I do to get my solutions? I'm going to divide or multiply by 1 over 2 pi. Okay, now how do I do that? Well, it's like multiplying this fraction by 1 over 2 pi. The pi's will cancel and the 2's will multiply, and I get a fourth. The pi's will cancel, the 2's will multiply, I get 3/4. 2 pi divided by 2 pi is 1. So that just becomes like integers. Add, subtract, ones. All right, a couple more. Just be careful. Sometimes you might have to do a couple extra steps to isolate the trig function before jumping into the solving. Here are my angles. My angles are pi x over 4. My angles of sine have to equal a half. I'm going to go to my pi over 6. I want my pi over 6 where sine is positive, so that's the pi over 6 here and the pi over 6 here. So I have 1 pi over 6, I have 5 pi over 6, and I have all coterminal angles. To solve for my solutions, I'll multiply everything by 4 over pi. What is pi over 6 times 4 over pi? Well, the pi's will cancel. I can divide the top and bottom by 2 to get 2/3. What is 5 pi over 6 times 4 over pi? I'm rushing now because I have to go to senior breakfast. Pi's cancel. 2/3. 2/3 times 5, so it's going to be 10/3. 2 pi times 4 over pi. Pi's cancel. This becomes 8. Cool. Add 3. Isolate the trig function. Figure out the angles. You can replace this with y too. I didn't really show that, but we can do that. When is tangent -1? That's going to be at the pi over 4s in the second quadrant and the fourth quadrant. All coterminal angles where k belongs to the integers. Multiply by 2, divide by 3 pi to get my solutions. Okay, so the 3's cancel, the pi's cancel. 2 over 4 is 1/2. Okay, the 2 becomes 1/2. Times 3 is 7/6, or it's like 14/12. 14/12 is 7/6. 2, right? 2 times 3 is 6. 3 times 4 is 12. 1/2. 2 times 7 is 14. 3 times 4 is 12. 14/12, 7/6. 2 times 2 is 4, divided by 3 pi, so 4/3. Multiples of 4/3. And we usually don't have to find any angles outside of the angles that we create from 0 to 2 pi in our solutions that then get manipulated in this class. Usually they just stick to 0 to 2 pi and its manipulations. Cosine equaling 1 is at pi, so at 0 and 2 pi. So my angles are 0 and 2 pi and multiples of 2 pi. So it's really just 2 pi. If you want to do that, you could just say it's 2 pi k, because that includes 0 if k is 0. Then I'm going to finish off by multiplying by 6 and dividing by pi to get my solutions. And then I'm going to go to senior breakfast. We are at that point where maybe my head covers up, so I'm just going to verbally say my answers. Multiplying by 6 divided by pi, this becomes 12. And multiples of 12. So really 12 plus 12k is 12k, because like you could subtract 12 and get 0. So you could just have 12 plus 12k, it's fine, or you could have 12k, it's fine. But that's it. If I was going too fast for you, I'd advise you do this homework twice. This is the only homework in which you're going to have one page. All your homeworks will have staples in it. I usually give you more space too. This should be familiar to you. However, I know some of you maybe forgot all about the unit circle over the summer. Don't be afraid of doing this a couple times if you don't remember how to do it. Because taking the extra time now will help you when I am just going to assume you understand the unit circle in the future. So please put in that time now. Come in and see us in the math office, and that's going to help you tremendously moving forward, okay? First quiz next class. I'll see you out there.